Hello guys, so this is the part 1 of our review for Math 171, Calculus 1 for Engineers. Okay, so bago tayo mag-start, let's see kung ano yung mga topic na i-discuss natin for this subject review. Okay, for the topics, here are the topic lists. Number 1, we have the introduction to differential calculus. Number 2, limits of functions. Number 3, continuity. Number 4, derivative of algebraic functions. Number 5, differentiation of algebraic functions. Number 6, rules of differentiation. Number 7, the chain rule. And number 8 is the higher derivative. So, konting reminder lang, if you are looking for a detailed discussion about this topic, then this video is not for you. But if you are preparing for an examination or for a quiz and you want to review these topics, then this is the right video for you. Okay, so let's start the discussion. Okay, first thing for us to discuss is about the evaluation of functions. So, paano nga ba natin i-evaluate yung ating mga functions? When we are evaluating functions, we will just simply substitute the value of this of your function. If we are getting for the function of negative 5, then we will be substituting the value negative 5 to our, since our original minus 4x, and we are tend to find the, if your x is negative 5, then again we will just simply substitute this value to the x here. Okay, so example number 1, if we have a function which is x squared minus 4x, and we are getting the function of negative 5, then simply substitute negative 5 to your x here and here. So negative 5 squared minus your 4 minus negative 5, and then negative 5 squared is equal to 25, and 4 times 5 is equal to 20. So if you will be adding 25 plus 20, then you will get 45. Okay, so if we will evaluate this function at the value of x, which is negative 5, our answer will be 45. Okay, next, let's try to evaluate this function. Example that we have is still the same function, which is x squared minus 4x, but we will be having the value of your x as your y squared plus 1. Okay, so substituting this value to your x and this part of your x here and here, therefore you will have a quantity y squared plus 1, closed quantity squared, minus your 4 open quantity y squared plus 1 closed quantity. Okay, so getting the y squared plus 1 quantity squared, that will become your y fourth plus 2y squared plus 1. Okay, and then you will be distributing this 4 to this y squared and 1. So minus your 4y squared, and then negative 4 multiplied by positive 1, so minus 4. So that will become y raised to 4 plus 2y squared plus 1 minus 4y squared minus 4. And then if you will be simplifying the equation, you can see that we have common terms here. 2y squared and the negative 4y squared, we can combine that, and positive 2 minus 4, that will become negative 2. And then this one is constant, these two are constant. So 1 minus 4, that will become negative 3. Our final answer will be y raised to 4 minus 2y raised to 2 minus 3. So this is the final answer if we will be evaluating this function. Okay, let's go to our next topic. Okay, let's see. So we have another example here for evaluation of functions. So what will happen if we will be evaluating the function x cubed, where your x has a value of your x plus delta x minus 4x over delta x, where your delta x is not equal to 0. Okay, so let's see if this is your equation, and then you have a value of x which is x cubed, and then right now we will be evaluating this function. Okay, so let's see. First, let's get the function of x plus delta x. Okay, in getting the function of x plus delta x, we will just simply substitute x plus delta x in our x cubed. Okay, so the function of your x plus delta x is equal to your x plus delta x cubed. Okay, and then if we will be cubing this equation, or if we will raise this into 3, then your answer will become x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Okay, so on the other hand, if you will get the function of x here, your function of x is simply equal to your x cubed, since it is just the same here. And then right now we will be finding this equation. So your f of x plus delta x minus the function of your x over your delta x. So we will be substituting the value here. We will get the value of your f of x plus delta x, function of x plus delta x. So we will get this value and then put it in here. This part, your x cubed plus 3x squared plus delta x plus 3x x squared plus x cubed, delta x cubed. And then we will get the value of your f of x here minus your f of x. So your f of x is x cubed, so you will be subtracting negative x cubed here. And then we have a denominator of delta x here. And then right now we will be combining the like value or the same same values or same with the same variable. So let's if we can see here, we have here an x cube and we have negative x cube here. So we can know that is 1 minus 1, so this is 0, cancel out. So the remaining will be 3x squared plus delta x plus 3x delta x squared plus delta x cubed. And then we will be dividing that equation into delta x. So this will cancel out. And then here we will have a 1 remaining, and then here we have 2. So the final answer will become 3x, cancel out squared, plus 3x delta x, because that will be removed, and then plus your delta x squared. Okay, so this is your final answer if we will be evaluating your function, uh, which is f of delta x, function of x plus delta x minus the function of x over delta x, where your function of x is equal to x cubed. Okay, let's go to our next topic, more on that evaluation of function. Let's go to the limit of functions. Okay, so in getting your limits or the limit of your function, you will just simply substitute the value of your a here and of your where your x approaches into the value of your x here. Okay, so example, we have here the limit of your x squared plus 2x minus 7 as your x approaches to 2. Okay, so if we will be solving that, the limit of your x squared plus 2x minus 7 as your x approaches to 2, we will be substituting 2 in your x here and then here. So that will become 2 squared plus 2, quantity 2 minus 7. So 2 squared is equal to 4. And then your 2 times 2 is also equal to 4 minus 7. And then 4 plus 4 minus 7 will be equal to your 1. Therefore, the limit of your function, which is the limit of your x squared plus 2x minus 7 as x approaches to 2 is equal to your 1. Okay, next, we will be evaluating the limit, which is your x squared plus 5x minus 3 as your x approaches to 3. So in order to evaluate that limit, you will simply substitute 3 on these values. Okay, so therefore that will become the limit of your the limit of your x squared plus 5x minus 3 as x approaches to 3 will be equal to your 3 squared there plus your 5 multiplied by 3 minus 3. Okay, so 3 squared is equal to 9. 5 times 3 is equal to 15. And then minus 3 minus 3. So 9 plus 15 minus 3, so that will be equal to 25. Okay, next, let's evaluate this limit. How about if our limit is on the indeterminate form, just like this example? Okay, so if we will consider this example, we have here the limit of your x squared minus 1 over your x squared plus 3x minus 4 as your x approaches to 1. So if we will be substituting 1 to your x here, that will become 1 squared, or that 1 squared minus 1, that is 0. And then here, 1 squared, that is 1, plus 3 multiplied by 1, that is 3, minus 4. So that is 1 plus 3 minus 4, or 4 minus 4, that will be 0. So that will become 0 over 0, or that is undefined, or it is on the indeterminate form. So in order to evaluate your limit, you need to do something about your equation, or you need to do something here. You may cancel out something here or some factors in here, so that you can evaluate your function without your denominator being 0. So in order to do that, let's factor out the two equations here. So the factors of your x squared minus 1 is x minus 1 and x plus 1. And then the factors of your x squared plus 3x minus 4 is x minus 1 and x plus 4. And then if you can see, they have common factors, which is x minus 1. And we have x minus 1 here, so you can cancel that out. And then the remaining equation will be x plus 1 over x plus 4. And then because of this, we have this equation. We can start evaluating it, or we can start substituting 1 for your x. So that will become 1 plus 1 over 1 plus 4. And then 1 plus 1 is 2, and your 1 plus 4 is 5. Therefore, if we evaluate, or we get the limit of your x squared minus 1 over x squared plus 3x as x approaches to 1, the value is 2 over 5. So that is the limits of function. So let's go to our next topic that we need to review, the topic of continuity. Okay, so it was said here that a function is said to be continuous at x is equal to a if the following conditions are all satisfied. So we have three conditions. First, your f of a must, or the function of your a must exist. And then also, the limit of your function of x as x approaches a must also exist. And then at the same time, the limit of your f of x as x approaches to a must be equal to the function of your a. So the value of this one and this one must be equal. So that is the three conditions, so that you can say that your function is continuous. Okay, so what well I know. So let's go. Okay, so for this, for the topic of continuity, we will be finding the discontinuity instead. Okay, so assuming that the equation is tested, and then that the equation was proved to be discontinuous, but then right now we will be finding the point of discontinuity of the following function. In order to get the point of discontinuity of a function, you just simply need to equate your denominator into 0. Okay, no, just like in this example, in order for this equation to be discontinuous, your x minus 5, or your denominator here, you will be equating it into 0. So equating that into 0, x minus 5 is equal to 0, so your x is equal to 5. Therefore, the point of discontinuity of the function 3x over x minus 5 is where your value of x is equal to 5, or it is discontinuous in the when your x is equal to 5. Okay, more examples for the point of discontinuity. Example that we have here, the equation 3x plus 2 over x squared minus 8x plus 15. Okay, so we will be finding the point of discontinuity from this function. So in order to do that, you will just simply equate your denominator into 0. So that will become x squared minus 8x plus 15 is equal to 0. And then we can factor this out. Okay, so the factor of your x squared minus 8x plus 15 is x minus 5, and then x minus 3. And then right now we will be, that your equation will be discontinuous at x is equal to 5 and x is equal to 3 if you equate this into 0 and equate this into 0. Therefore, we have 2 point of discontinuity. X is equal to 5 and x is equal to 3. Okay, so more on that. Let's go to the next topic, the derivative of algebraic functions. Okay, so for the derivative of algebraic functions, we will be discussing about the three-step rule, or the the differentiation of your equation using the three-step rule. So we have three steps for this. Step number one, write down the expression for the function of x plus delta x minus the function of x. Okay, there you will just get the expression of your the function of x plus delta x minus the function of x. And then you will divide that result in the step 1 by delta x. Okay, just like that, like just like this. The function of your x plus delta x minus the function of your x over delta x. And then after that, you will be simplifying it again. And then the step 3 is to find the limit of the result in your step 2 as delta x approaches 0. So you will be getting the limit of your, and you will be getting the limit of your, the function of your x plus delta x minus the function of x over delta x as your delta x approaches to 0. And then if you get that limit, you will get your dy over dx or your derivative for that function. Okay, let's try using the three-step rule here. We'll find the derivative in each using the three-step rule. So we will be finding the derivative of this equation using our three-step rule, which we have discussed a while ago. Okay, so we have here your y is equal to x squared minus 4x plus 5. And let's find its derivative. So in order to find its derivative, first step, let's get the function of your x plus delta x minus the function of your x. So the function of your x plus delta x could be obtained when we substitute your x plus delta x to this equation, which is x squared minus 4x plus 5. Okay, so first we have your x plus delta x squared minus your 4x plus delta x plus your 5. And for in getting your f of x, so that will become minus your x squared minus 4x plus 5. So your f of x is x squared minus 4x plus 5. So simplifying this equation, your equation which is x plus delta x squared minus 4 quantity x plus delta x plus 5 minus quantity x squared minus 4x plus 5. If we will be simplifying that, so we will have your x squared here, but your x squared will be cancelled out with this negative x squared here. So the remaining will be your 2x delta x plus your delta x squared, okay, minus your negative 4x will be cancelled out with this, that is positive 4x, so cancel out, minus your 4 delta x. Okay, and then your plus 5 and minus 5 will cancel out. So the remaining will be your 2x delta x plus delta x squared minus 4 delta x. And then if you will be getting this common factor, which is delta x, we will be putting it here. So your delta x is equal to your 2x, quantity 2x plus delta x minus 4. So the function of your x plus delta x minus the function of x is equal to your delta x quantity 2x plus delta x minus 4. Okay, so the next step after getting this, the value of this, we will be dividing this by delta x. Okay, so dividing the function of your x plus delta x minus the function of x with delta x, so that will be equal to your delta x quantity 2x plus delta x minus 4, and then you will be dividing it by delta x. So simply cancel this out. So we will be having your 2x plus delta x minus 4. Okay, so then the last step, you will be getting the limit of the function of your x plus delta x minus the function of x over delta x. As your delta x approaches to 0, so you will be substituting 0 to your delta x. So this will become 2x plus delta x minus 4. If we will be substituting 0 here, so this will become 0. So the remaining will be 2x minus 4. So this will be 2x minus 4. Therefore, this will be your final answer. And then the derivative of your function, which is equal to the limit of the function of x plus delta x minus the function of x over delta x as delta x approaches to 0 is equal to 2x minus 4. Okay, so next, let's go to another problem for your three-step rule. So find the slope of the curve at the given point. So we know that the curve of the curve or the slope of the curve is equal to the derivative of the function, or the first derivative of this function. And then you will just simply substitute the points of the given point. So in order to get the slope, you simply derive this or differentiate this. I mean, you need to differentiate this with using your three-step rule, and then after the differentiation, you will be substituting the value which is your x as 1 and your y is 4. So first, let's go to our three-step rule. Let's get the function of your x plus delta x minus the function of your x. So getting the function of x plus delta x, so that will become 3 plus your 2x plus delta x minus your x plus delta x squared minus the function of your x, which is your 3 plus 2x minus x squared. Okay, so simplifying this, so this will become 3 plus, distribute this, 2x plus delta x minus the x squared of this is x squared minus 2x delta x plus delta x squared minus your 3 minus 2x and then plus x squared. Okay, so after that, let's, I don't know, remove the parentheses here, and then so that we can get the answer, or we can simplify your equation. So we will be having your 3 plus 2x plus 2 delta x minus x squared minus 2x delta x minus delta x squared minus 3 minus 2x plus x squared. So we will be canceling out this. Your 3 will be cancelled out. That is 3 minus 3. That is common term with different sign. Delta x squared will also cancel out. Your 2x will also cancel out. And then the remaining will be your 2 delta x minus your 2x delta x minus delta x squared. Okay, so this will be the remaining in her equation, and then as we can see, we have a common term which is delta x here. We have delta x here and delta x, so we will be, I know, we will be putting aside the common term. So that is delta x quantity 2 minus 2x minus delta x. So we factored out delta x there. And then after that, let's go to the next step. We will be dividing the function of x plus delta x minus the function of x by delta x. So that will be equal to your delta x plus 2 minus 2x minus delta x over your delta x. So your delta x will cancel out. So the remaining will be 2 minus 2x minus delta x. And then the last step for our three-step rule is that we will be, I know, finding the limit of your, I know, the function of your x plus delta x minus the function of your x over delta x as your delta x approaches to 0. And then this function is equal to your 2 minus 2x minus delta x, where your delta x approaches 0. So we will be substituting 0 here. So your equation will be 2 minus 2x, that is 0. So 2 minus 2x. Okay. And then after that, you know that the first derivative of your function is equal to 2 minus 2x, and then in getting the slope of your curve, we will simply substitute the value of your 1 and 4 on your x and y. So for this, in getting your slope is equal to your y prime, or your, the first derivative of your function, which is 2 minus 2x. So 2 minus 2x in here, and then we have the value of x, which is 1. Your y is 4. So we don't have a y here. We only have the x. So we will substitute 1 into your x here. So that will become 2 minus 2 quantity 1, or 2 minus 2, therefore it is equal to 0. So therefore the slope of your curve is 0. Okay, let's go to the next topic. Next topic, let's go to the differentiation of algebraic functions. So here we will be using the different laws of differentiation. Okay, so let's have this example. Okay, or the different rules for differentiation. Let's use the different rules for differentiation. So differentiate the following function. The function is equal to y is equal to 5x squared plus 7x plus 10. So using your power rule, we will use your power rule here. If you can, I know, still remember, your power rule is your, I know, n, which is, I know, or your x raised to n minus 1, and then you will put the n here multiplied by your n. Therefore, this is x squared, or your x is, ano, that is, ano, your, ano, is 2 here. You will be subtracting 1. So that will become 1. So that is x na lang, x raised to 1. And then 2, I know you will be putting it here as, ano, multiplier. So 2 times 5, that will become 10. Or that is 10x using your power rule. Okay, for the same here, you will be using your power rule. So that is 1. 1 minus 0 is 0. So x raised to 0 is equal to 1. And then you will be bringing down here the 1. So 1 multiplied by 7. So that will become 7 times 1, or that is 7. So using your power rule, that is 10x plus 7, since this is constant. So the derivative of your constant is equal to 0. So the derivative of your y is equal to 5x squared plus 7x plus 10, as you use your rules for differentiation, is 10x plus 7. Okay, the same true with this. We have 3x raised to 6 minus 7x squared plus 10. So here we have 6 times 3, that is 18, and then x, and then 6 minus 1 is 5, so that is 18x raised to 5. And then here 7 times 2, that is 14, and then x raised to 2 minus 1 is 1, so this is raised to 1. So that, and then this is constant. The derivative of constant is 0. Okay, so your the derivative of your function is equal to 18x raised to 5 minus 14x. Okay, next, let's go to more of that, more example for your differentiation of algebraic function. So we will be having the derivative of your 5 over 3x squared over 5. So using the quotient rule, your quotient rule is your VDU minus UDV over V squared. So this is your u, this is your v. So your v, or your 3x squared minus 5 here. So this is 3x squared minus 5, and then you will multiply it by the derivative of 5, and then the derivative of 5, or your constant, is 0. So 3x squared minus 5 multiplied by 0 is 0. So that will become 0. There is an imaginary 0 here. And then minus your u dv, or that is your u is 5, and then we will get the derivative of this. The derivative of this is 3 times 2 is equal to 6x raised to 2 minus 1 is 1. So this is 6x. And then minus that is 0, since that is a constant. So the derivative of your denominator is 6x. So that will become 0 minus your 5 multiplied by your 6x over your, here, I know the v squared, or the 3x squared minus 5 squared, denominator squared. Okay, so simplifying this equation, 5 times 3 is equal to negative 30. So that is negative 30x over 3x squared minus 5 squared. So this is the derivative of your function. Okay, so for here, we have here 3x squared minus 2 multiplied by 4x squared plus 5. So this, we will be using the multiplication rule of your differentiation. For the multiplication rule, that is your, if this is your u term, or u, and this is your v term, so we will be having your u dv plus v du. Okay, so your 3x squared minus 2 multiplied by the differentiation of this, and if you derive, or if you differentiate this, this will be equal to 4 times 2, 8. That will become 8x. Okay, that is 0, so 8x. And so this will become 3x squared minus 2 multiplied by 8x plus this, your 4x squared 5 multiplied by the derivative of this. So if we differentiate it, this will become 3 times 2, 6. So that is 6x. Okay, 6x, and this is 0 if you differentiate that. So the derivative of your 3x squared minus 2 quantity 4x squared plus 5 is 3x squared minus 2 quantity 8x plus 4x squared plus 5 quantity 6x. If you will be simplifying this, if you distribute this 8x here. So this will become 24x cubed. This is 16x. And then here, 6 times 4, that is 24x cubed. And then 5 times 6, that is 30x. So we will be combining the like terms here. And then we will combine this part. So that is 24 plus 24, that is 48x cubed. And then 30 minus 16, that is 14x. So the derivative of your 3x squared minus 2 quantity 4x squared plus 5 is equal to your 48x cubed plus 14x. Okay, let's go to some application of differentiation. Okay, so ito, we will have the slope, find the slope of your function, which is 2 minus x squared at the point 3, negative 7. The same with the, I know, the theory that we have used a while ago in getting the function. You know that the slope, I mean, if in getting the slope of a function, you just simply get the first derivative and then substitute this value of your x and y. Okay, so if your function is equal to 2 minus x squared, if so the first derivative of that is equal to derivative of constant, that is 0, and this power rule that will become negative 2x. So your first derivative is negative 2x, and then we will be substituting the value of x here. We have 3, so negative 2 multiplied by 3, that is positive 3. This is typographical error. So negative 2 plus 3, that is negative 6. So the slope of your function is negative 6. Okay, more of the application. Let's have the, let's find the vertex of the parabola, which is 1/8 quantity x squared plus 8. Okay, so in getting the vertex of your parabola, you just simply get the first derivative of your function, and then after getting the first derivative of your function, you will be equating your derivative by 0. And then if after you equate the first derivative by 0, you will get the value of your x, or the value of your x, and then in getting the value of your y for the point of vertex, or the vertex, and then you will just simply substitute the value of your x to your original equation. So what I mean is this. Okay, so example, we have here your y is equal to 1/8 of quantity x squared plus 8. So let's get the first derivative. In getting the first derivative, that is the 1/8, and then the derivative of your x squared plus 8. We can put the constant here since it is just the coefficient of your x squared plus 8. So that will become 1/8, and then the derivative of your x squared plus 8 using the power rule, this will become 2x, and then this is will become 0 since that is constant. So the derivative of x squared plus 8 is 2x multiplied by your coefficient 1 over 8. So that will become 1/4 x. Okay, so the first derivative of your function is 1/4 x. So we will be equating that into 0. So that is 0 is equal to 1/4 x. So getting the value of your x, so you will be multiplying this by 4. So your x is equal to 0. Okay, the point, or the x coefficient of your vertex is 0. And then for getting the y, you will just simply substitute your x is equal to 0 to your original equation. So your y is equal to your 1/8 x squared plus 8, substituting 0 in your x. So that will become 1/8 quantity 0 plus 8. And then 0 plus 8 is 8. And then 8 divided by 8, that will become 1. So your y is equal to 1. Therefore, okay, your point, or the vertex, your vertex is located at 0, 1 of your Cartesian plane. Okay. Next, let's go to your the point where the tangent is parallel to the x-axis. Okay. So we will be getting the point of this function where it will become parallel, or tangent. The tangent will be parallel to your x-axis. Okay, so in getting that, you will just simply get the first derivative of this function. And then after getting the first derivative of this function, you will equate it into 0. And after equating it into 0, you will get the value of your x. And then, of your x coordinates. And then after getting the, value of your x coordinate, you will just simply substitute the value of your x coordinate to the original equation, and you will get your y coordinates, and then you will get the point where the tangent is parallel to your x-axis. Okay, so let's do this. If we have the equation 2x cubed minus 3x squared minus 2x minus 12x plus 6, so we will be getting its derivative, or we will be differentiating this. So we will have your 2x cubed power rule, so that will become 6x squared, and then this power rule also, so that will become 2 times 3 6, so 6x minus 6x power rule, that will become 12 minus 12, and then this will become 0. So the first derivative will be 6x squared minus 6x minus 12, and then you will be equating that into 0 as I have said earlier, so that you will get the x coordinate. And then after equating that to 0, you can see here that you can factor out 6 from this, so that will become 6x squared minus x minus 2, is equal to 0. So if we will be getting the factors of your x squared minus x minus 2, that is x minus 2 and x plus 1. So your equation will be 6. Quantity x minus 2, quantity x plus 1 is equal to 0. And in getting the value of your x, so you will be equating this into 0. Therefore, your x is equal to 2 and x is equal to negative 1. So these are the two x coordinates for the points that we are finding. After that, we will be substituting these values into your original equation or to your function. Therefore, substituting your x is equal to 2 to solve for the y coordinate. So your y is equal to 2x cubed minus 3x squared minus 12x plus 6. And then substitute the 2 for the x. So your y is equal to 2 raised to 2 cubed minus 3 raised to 2 squared minus 12 raised to 2 plus 6. And then if you will be simplifying this will become 16 minus 12 minus 24 plus 6. And then your y will be negative 14. Okay, so the first point is at 2 negative 14. For the second point, we have x is equal to negative 1. Substitute to your function. So your y is equal to 2x cubed minus 3x squared minus 12x plus 6. And then you will substitute negative 1. So that will become 2 negative 1 raised to 3 minus 3. Negative 1 squared minus 12 multiplied by negative 1 plus 6. So that will become negative 2 minus 3 plus 12 plus 6. And then your y is equal to 13. Therefore, your second point is at negative 1, 13. So these are the two points where the tangent is parallel to your x-axis. Okay, so those are the application for your differentiation. Next, we have the chain rule. So what is this chain rule? So this chain rule is applicable when you are differentiating or you are finding the derivative of a function that could not be differentiated using the rules that we have discussed or the basic rules of differentiation. Therefore, you will be combining those rules in order to find the derivative. That's why it is called chain rule because we will be combining several rules of differentiation in order to get the derivative of your function. Okay, example, we have here a function which is the quantity x squared minus 3x plus 1 raised to 4. So getting its derivative, it is simply equal to using your power rule and then treating this as your u or your x. So this will become 4 x squared minus 3x plus 1 raised to 3. That is, I know, you just 4 times 1 and then 4 minus 1, that is 3. So next, we are not yet through because as you can see, you still have the derivative of this. So you can, getting the derivative of your inside equation. So that will become 2x minus power rule 3x plus 0. So that is 2x minus 3. So your du is equal to 2x minus 3. Okay, so this will become the derivative and then simplifying that. So we will be having your 4 quantity 2x minus 3 quantity x squared minus 3x plus 1 raised to 3. So as you can see, we could not finish this with your power rule since the inside is still we didn't it still has a derivative. Okay, so so that we have your 2x minus 2 here. Okay, next for the chain rule example, we have your y is equal to the square of your 5 minus 3x. So getting that or getting the derivative of that, so we will be using the formula of your your square of u, that is du over dx over 2 squared of u. So your d over dx, okay, is this, diba po? Or for this, we have the derivative of your 5 minus 3x is equal to, this will become 0, this will become negative 3. So your d over dx is negative 3 over your 2, and then your u is square root of 5 minus 3x. So we'll just copy that. So the derivative is equal to negative 3 over 2 square root of 5 minus 3x. Okay, so this is the formula, one of the formula for chain rule. The derivative of your square root of u is equal to d over dx over 2 square root of u. And then for here, the derivative of your the derivative of your power rule of your u is equal to, or your d over dx of your u is equal to, what is this? Your u, and that is u n minus 1 is the nu, I mean n minus 1 multiplied by your du. Okay, so you can check it on your notes because it is hard. And then here, so last topic, we will have your higher order derivatives. For your higher order derivatives, you will just differentiate your equation several times depending on what is needed. Just like on this example, we will be differentiating it by 3 because it is in y third prime. Okay, so we will be differentiating this into 3, or it is on the third order derivative. So first, let's go for this. We have the function which is x cubed minus 2x quantity squared. So getting the first derivative, okay, so that will become 2. I will just put that here, x cubed minus 2x, and then the derivative, raised to 1, and then derivative of the inside, that is 3x squared, power rule, 3x squared, and then this will become minus 2x, minus 2, I mean. So the first derivative will become 2, quantity x cubed minus 2x, quantity 3x squared minus 2. And then, getting the second derivative, okay, so we will be differentiating your first derivative in order to get the second derivative. So that will become your 2. Okay, this is product of rule. So your x cubed minus 2x multiplied by the derivative of your 3x squared minus 2. This will become 6x. This will become 0. So that is 6x. So that is x cubed minus 2x multiplied by 6x plus your 3x squared minus 2 multiplied by the derivative of this by the, because of the product rule. So the derivative of this will become 3x squared minus 2. 3x squared minus 2. Okay, so this will become your second derivative, simplifying that. So you'll have your 2, and then you, I know, distribute this. So this will become 6x raised to 4 minus 12x squared plus, okay, we will be multiplying this. So that is 9x raised to 4, and then that is minus 6x minus 6, so that will become negative 12x squared minus 2 minus 2, that is plus 4. Okay, there is a bracket here. So simplifying it further, this is like term, so 6 plus 9, you can add that. This is also, we can combine this part. So this will become your 2, quantity 15x raised to 4 minus 24x squared plus 4. Okay, so this is your second derivative. Okay, lastly, let's go to the third derivative. We are finding the third derivative. For your third derivative, we'll be differentiating this second derivative. So that will be equal to 2. This is power rule, 15 times 4, 60. 4 minus 1, that is 3. So 60x raised to 3. And then power rule of this, 24 times 2, 48. And then 2 minus 1, that is 1. So 48x. Okay, and then derivative of your constant is 0. So that will become 2, quantity 60x cubed minus 48x. Then let's, I know you can factor out 24 here as a common term, or I mean 12. They are divisible by 12. So your 12 times 2, that is 24x. And then this 60 divided by 12, that is 5x squared. 48 divided by 12, that is 4. 5 squared minus 4. So this is your third derivative. So the third derivative of your y cubed minus 2x quantity squared is equal to 24x quantity 5x squared minus 4. Okay, last example for your higher derivative. So we have here your function, which is x over x plus 1. And then we are finding the second derivative of this. So first, let's get the first derivative. For the first derivative quotient rule, that will be equal to your x plus 1. X plus 1 multiplied by the derivative of your numerator. So that is 1, imaginary 1 here, minus the numerator, which is x, multiplied by the derivative of your x plus 1, which is also 1. Okay, and then your denominator is squared, so x plus 1 is squared. So your first derivative will become x plus 1 minus x over x plus 1 squared. And then if you will be simplifying that, if you can see your x minus x, that is 0. So the numerator will be 1. So that will become 1 over x plus 1 squared. That is your first derivative. Okay, in order to get your second derivative, you will simply differentiate your first derivative. Okay, so in getting that same, we will be using the quotient rule. So we will have the denominator, which is x plus 1 squared, multiply, so that is x plus 1 squared, multiply by the different derivative of 1, which is 0. So that will become 0. So 0 minus your numerator, that is 1, multiplied by the derivative of this, so that the derivative of your denominator is 2x plus 1 raised to 1. Okay, and then derivative of x plus 1 is 1. So that is imaginary 1 here. So your numerator is negative 2 x quantity x plus 1 over your denominator squared x plus 1 raised to 4. Okay, so simplifying your equation, that will be equal to your, if you can see, x plus 1 is, I don't know, common, so we can cancel this out. This will become raised to 3. So your second derivative is negative 2 over x plus 1 raised to 3. So that is the second derivative of your equation x over x plus 1. And the derivative of that is negative 2 over x plus 1 raised to 3. Okay, so that's all. That is all the topic for our review of our Calculus 1 for engineers. And then we have tackled all the topics. So I hope that you have learned what you need to learn, and then in order for you to pass your examination and your quizzes. So I hope that this review helped you. And then again, if you can, if you need a detailed discussion of these topics, then you can refer to our discussion on our Google Classroom. But for the meantime, this is the review for all of the topics for the part 1 of your Calculus 1 for engineers. So I will be uploading this Google Jamboard on our Google Classroom, so that you can have the reference there, or for your reference purposes. So that's all. So see you again for the part 2 of your Calculus 1 for engineers review. So good luck for your exam and your quizzes. Thank you guys, and goodbye.